Hello, young math Padawans. Let's take some quick notes on, is it a function? So before we begin, we have to answer this question, what is a function? So a function is a very special type of relation. As we recall, a relation is what maps a specific input x to a specific output y. What a function tells us is that each input x has its own unique output y. The best way to describe a function is to think of it like a vending machine. So imagine you have a vending machine with various products, and then you have your keyboard over here with different letters for each product. So imagine on the vending machine I select A1, and A1 means that I'm going to get chips. This means that every time I press A1, or this is my input, my output should be chips. Now, what if someone came in behind me and pressed A1 again, but this time instead of chips, they got pretzels? You would say that this vending machine is not functioning correctly because the same input, A1, produced a different output, pretzels. So a function means that every input has its own unique output. There could be two different inputs, like A2 also gives me chips, but as long as the input is unique, this is considered functioning correctly. So let's take a look at our examples. Example number 1, we have a set of inputs, 7, 5, 3, 1, 3. And after a specific relation, we have a set of outputs, 4, -1, -9, -5, and 6. So is this a function? Well, it's only a function if each input is mapped to a very specific output. So I notice here that the input 3 is used twice, and it's producing two different outputs, -8 and 6. That would be like pressing the button 3 two different times and getting two different products. This is not what we would call functioning correctly. So this relation is not a function. And the reason why is because the input 3 has two different outputs. Let's take a look at our table. Well, looking through, my inputs are each unique, -3, 0, 3, 6, and 9. None of these are repeating, and each of them has their own unique output. Therefore, if this was a vending machine, we would say that this is functioning correctly. So this is an example of a relation that is a function, because each input has its own output. Or in other words, the same input was not used more than once. Let's take a look at our mapping diagram. Now this really makes me feel like I'm looking at a vending machine here. So in this case, I'm pressing 5 possible different numbers on the vending machine, and these are the different products that I'm getting. Some of you might think this isn't functioning because there's 2 inputs for 1 and there's 3 inputs for 2. But hold on, remember on a vending machine, you can press 2 different buttons for the same chips, or 3 different buttons for the same pretzels. So we would say that this is functioning correctly. This relation here is an example of a function because each input is only used once and has its own output. Finally, we have our graph. This one is a little hard to see. On our x-axis are all of our inputs, and along the y-axis would be considered all of our outputs. So, is each input only used once? Well, I don't think so. Here I can see that 0 is being used twice. The first time 0 produced 2, and the second time 0 produced 4. The same can be said for 2 and 4. So since our inputs of 0, 2, and 4 are being used more than once, we would say this is not a function. And the reason why is because our inputs, 0, 2, and 4, are used more than once. And there you have it for this quick video on Is It a Function? See you next time.